Welcome back, students. Today is the session 27 of NEET Physics. The chapter is rotational motion, and in this session, I have taken this question which was asked in the CBSE All India Pre-Medical Test in 1992. So this the question is the speed of a homogeneous solid sphere after rolling down an inclined plane of vertical height h from rest without sliding is. So we have to find the. So let us understand this question with the help of this diagram. So this is the inclined plane. This is the topmost point of this inclined plane. This is the base of this inclined plane, and this is the bottommost point. So we have to find the speed of a homogeneous solid sphere after rolling down an inclined plane of vertical height h from rest. So we have to find the speed of this solid sphere when it reaches this point B from this point A. So this solid sphere is placed at this point A, and it is in this question it is written that this solid sphere is at rest. So now it starts sliding, it starts rolling down from this point A towards B and without sliding. So in that case we have to find the speed of this solid sphere when it reaches this point B. So here what we will be doing is we will be using the law of conservation of energy. Law of conservation of energy. And using this law of conservation of energy, we will be able to find the speed of the solid sphere when it reaches the point B. So now at the point A, total energy of this sphere is equal to mgh, because at this point the sphere is at rest, and it is only having the potential energy due to the vertical height of this inclined plane. The vertical height of this inclined plane is h. That is, this height is h. That is, OA is equal to h. So at A, the total energy of this solid sphere will be equal to mgh. That is, it will be having only the potential energy by virtue of this height of this inclined plane. So when it rolls down from this point A towards the point B, this energy will get converted into the kinetic energy. So by the law of conservation of energy, this total energy at this point A, or we can say that total energy at A will be equal to the total energy at the bottommost point B. Okay, so this is the relation which will be using it in order to find the speed of the solid sphere. So now the total energy at A is mgh. At B, the total energy at B, the total energy of the solid sphere at B will be equal to total energy will be equal to the sum of the rotational kinetic energy plus the I will be writing it here because there is no space here right now, so I will be just writing this statement here. That is, total energy at B, total energy of this sphere at B this will be equal to sum of the rotational kinetic energy plus the translational kinetic energy. So this total energy of the sphere at this point A, that is which was equal to mgh, will get converted into the total energy, should be equal to the total energy at the point B, and the total energy at the point B will be equal to the sum of this rotational kinetic energy, because it will be this solid sphere will be coming from this point A to point B by the rolling action, and so this this solid sphere will have that is the total energy at B will be equal to the sum of the rotational kinetic energy plus the translational kinetic energy. Now so we can say that is mgh. This is the total energy of the sphere at this point A will be equal to the translational energy of this solid sphere, that is equal to half mv square plus the rotational kinetic energy, which is equal to half I omega square, where omega is the angular velocity and I is the moment of inertia. Now the moment of inertia of a solid sphere, that is the moment of inertia of a solid sphere about the diameter will be equal to 2 by 5 m r square, where m is the mass of that solid sphere and r is the radius. So I will be substituting this moment of inertia and this is equal to I. So I will be substituting this value in this equation, and omega is the angular velocity, and omega, and we know that v is equal to r omega. So omega is equal to v upon r. So I will be substituting the value of omega, which is equal to v by r, in this equation, and the value of I will also be substituted in this equation, and so by using the value of I and omega in this equation, we will be able to derive the value of v. V is the speed of this homogeneous solid sphere at this point B. That is the bottommost point. So it implies that mgh is equal to half mv square plus half I, that is half I is equal to 2 by 5 mr square, and omega is equal to v by r, so that will be equal to v square by r square, because this is omega square, so this will be equal to v square by r square. So in this way, what we are getting here is, it implies that here you can see that 2 and 2 will cancel out, r square and r square will also get cancelled out. So I am getting as mgh is equal to half m v square plus mv square 1 by 5 mv square. So this is the equation which I am getting right now here, and now what I will be doing is I will be solving this equation here. That is, it implies that mgh is equal to half mv square plus 1 by 5 mv square. So this m will get cancelled out. So we will be getting as mg, that is gh is equal to half v square plus v square by 5. So it implies that gh is equal to, I will be taking the LCM of 2 and 5 is 10, so it will be equal to 5v square plus 2v square. So this, it implies that 7v square is equal to 10gh, or it implies that v square is equal to or we can simply say that V is equal to under root 10 by 7 GH. So the speed of this homogeneous solid sphere when it reaches the bottommost point of this inclined plane will be equal to under root of 10 by 7 GH. So in this case, our option will be the correct option is A. That is, here it is written, it was written as 10 by 7 root 2 GH. Oh, sorry, this option is A is correct, which is under root of 10 by 7 GH. So in this question, the most important thing for us to understand is that we have to apply the law of conservation of energy. And the second point was that at this point A, this sphere was the total energy of the sphere at this point A was equal to mgh. That is, it was having the potential energy by virtue of this vertical height of this inclined plane, and this energy got converted into the sum of the rotational kinetic energy and the translational kinetic energy at the point B. That is, at the point B, this entire energy got converted into the kinetic energy. And using the law of conservation of energy and using the concept of that is total energy at A is equal to total energy at B, which was equal to the sum of the rotational kinetic energy plus the translational kinetic energy. So by using this equation, we were able to find the value of this speed of the homogeneous solid sphere at the bottommost point B. So the correct option is A, that is under root 10 by 7 GH. And so thank you very much for joining this session. I hope you have understood the solution of this question. In the next session, I will be coming up with some different type of questions pertaining to the same topic. So thank you very much. Have a nice day. Bye.